Welcome, Precalc. Welcome, welcome. Let's get set up for you today. Welcome, welcome, everyone. Welcome. Let me get you guys set here. Set up these guys. How are we doing today? Doing pretty decent? Welcome, everyone. Hi, everyone. Hello, hello. Happy National Online Learning Day. We're doing it. We're celebrating. In order to celebrate, tell us in the chat one random, boring fact about you. Interesting facts? I'm out of interesting facts. I'm not interesting anymore. And so I think it's just, I saw this on Instagram. I was like, this is how I'm feeling. Like, interesting facts are like very hard to come up with. So tell us a random, boring fact. My random, boring fact is that my hairbrush is red. You didn't need to know that about me, but now you do. That's what it is. I'm 4 years away from being 20 years. Yes, excellent. Love that fact. Even a little bit of math in there if you want to figure out an age. What a great holiday, said no one. Bummer. I think it's a great holiday. I think we should be celebrated for doing this. So yes, another boring fact. What could it be? Ooh, I use avocado shampoo, which is a boring fact, but you want to know the unboring part about it is that I use avocado shampoo, but my boyfriend is allergic to avocados. So sometimes he's like a little worried about my hair and smelling my hair because like, what if he's allergic like by drafting it? I don't know. Axel's fact. I have a twin brother. Excellent. I don't have a cat. Great. Such a boring fact. I was reading on Instagram this idea about having a boring fact. And one of the facts that came up was that someone eats a pound of turkey a day. And I was like, sir, that is an interesting fact because that sounds very unhealthy. I mean, I guess better than eating like a pound of steak a day, but like not as good as eating a pound of vegetables a day. But that seems strange. Yes, I don't know. So anyways, some facts for you. I'm loving these facts in the chat. My favorite show is The Office. Excellent. If anyone has a random boring fact that they would like to share with us throughout the rest of class today, feel free, drop it in the chat. You can privately message it just to me. I might even throw some of them on Instagram. We'll see. Thank you to those people who have their cameras on. If you are able to turn on your camera, that would be awesome. Helps me to not like just talk to a bunch of squares. Super, super helpful. Wow, Galilee, don't mess with anyone for their facts. Theirs are supposed to be boring facts. Guys are funny. Left-handed. Kimbo is left-handed. Do we have any other lefties in the house? Any other lefties? David Lopez is a lefty. It sucks, yeah. Did you know that there are statistics? Okay, so one in lefties, you probably know this, but maybe righties, I don't know if you know this. So 1 in 10 people are left-handed, like 10% of the people. And if you are, thank you to people who are messaging me about your cameras. It's okay. You don't have to message me, but thanks for letting me know. 1 in 10 people are lefties. We've had roughly 40-ish presidents, which means we should only have like 4 lefty presidents, but we've had like 10 lefty presidents. Did you guys know this? Someone can probably fact check me. There are probably, you can like Wikipedia it or something, but they have, yeah, I don't know. Very interesting. There has been way more lefty presidents than there should be. And a lot of lefties are always like, yeah, that's because lefties are the best. But David Lopez says it sucks. So, you know, David, Diana, Kimbo, Obama was left-handed. To me, it doesn't suck. Wow, interesting. Okay, so it looks like we have 3 lefties in our class, which makes sense. We have about 30 people in our class. That's about 10%. We'll see. We should check. We should see grades. See if lefties are getting better grades than non-lefties. What do you guys think? Maybe? Diana's like, yeah, for sure we get better grades. Yes. Excellent. Don't check my grade. All right, we'll leave that for another time. Some people think it's great to be lefty. Wow, that's an awesome aside. I'm loving this self-5 gif right now. This is how I'm feeling about life in terms of like, yeah, I went for a high five and then I just gave it to myself. So just one more time. Here is the password and chat. Galilee, I know you got me. Keep reposting that if you see more people jump on. Cool. Today's agenda is we're going to talk about one college rep who is coming on Thursday. We're going to do the notes and then the assignment. So jumping into college rep, Soka University is coming on Thursday. As you guys know, your PT will be about a college rep visit. No, it won't. Your PT will be about a college and graphic design. And the first part is research. So there are two options for research. The first one is like a document where you do research of a college on your own. And then the second one is going to a college rep visit. So you can do one of those. You can do both technically, but like you only need to do one of those. So either like a document, if you're like, I hate documents, I'm doing too many documents, I hate this online learning stuff. No talking bad about online learning on Happy National Online Learning Day. But if you are drowning in documents, you could go to the college rep visit instead, okay? That will be an assignment in week 10, right? So the last week of this quarter, in week 10, you will have an assignment and you will either say, I went to a college rep visit and this is what I learned, or you will say, I'm gonna you'll do some research and you'll write that down on the document. Does that make sense? Those two options. Yeah. I know in some of our brains, we thought, yeah, wait, I thought there were 9 weeks in quarter one. There are 10 weeks in quarter one. There sometimes are 8, sometimes 9, sometimes 10. It depends on the calendar. But this year there are 10. So you have the rest of this week, which is week 7. We're in week 7 right now. We have next week, which is week 8. You have the week after that, which is week 9. You're going to take the ACT at the end of week 9. So normally, you know how you would take your interim at the end of week 10 or like the last week. This year, you're like this quarter, you're going to take it 1 week early, just in case there are like technology fails or whatever. So 7 is this week, 8 is next week, 9 is the week after that. That's when you're taking your interim test, your ACT. And then week 10 will be the last week. And that will be the week that we are doing the PT work. Are there any questions about the next 4 weeks? No? Cool. Okay. That also means there are only 4 weeks left in this quarter. So if you are someone who is like, shoot, I need to turn in some missing assignments, now would be a good time to do it. If you're someone who's like, shoot, I need to do retakes, now would be a good time to do it. So you can do both of those things right now. The retake process is exactly the same. You do the practice problems, you fill out the Google form. That's it. That's how you take a retake. Does anyone have any questions about PT, the last couple weeks of school, college rep visits, resubmissions? Okay. Missing assignments are right now worth about 4 to 5% on your grades. So if you have a missing assignment, you are down 5%. A not yet on your quiz is bringing you down about 4% as well. So if you have any not yets, you can make your grade go up 4% by completing the retake. So that's pretty simple. We'll probably have we will have one more quiz before the end of the quarter. So it will balance out a little bit. You will have time to do retakes though, so no big deal. Cool. All right, we're done with that. We are gonna jump into the notes. You do have access to a video note section. So I'm actually gonna show you. No, I'm just gonna tell you. So today you have access to video notes. If you're someone who learns better from a video, then you are welcome to listen to that video. It is on Canvas, posted already. You can take notes on there and then start on your assignment when you're done. If you are someone who would prefer to learn from me, I call that live action. And we are going to jump into live action right now. So you can grab your paper, pencil. We are working on notes 8. We're working on notes 8, which is about inverses. So I'm going to give us about 60 seconds to get set up here while I fix my screen share. And then we will jump into our notes, which are on inverse relations today. So take a 60-second breather if you need to like stretch out. I know it's like early. I need to like move my shoulders back a little bit. And then we'll jump in. All right, give me a thumbs up if you can see my screen. Awesome. Cool, guys. Thank you. And make sure I can get this chat back. All right. Cool, y'all. Okay. We are going to learn about inverse relations today. I know that you talked about this with Miss Joelle. So hopefully it'll be like a little bit of a review. If it's not, that's totally fine too. So I will talk about it like you don't really know anything. And then you can tell me what you know already. So when you hear the word inverse, what does that make you think of? Hear the word inverse. Opposite, for sure. So we often talk about inverse meaning opposite, like inverse operations are like addition and subtraction. They're opposites of each other. In particular to a relation, what's the inverse of a relation? It's the interchange of X and Y. The interchange of X and Y. So basically we're taking all the X's, turning them into Y's, all the Y's, turning them into X's. For notation's sake, notation is like how you write it down. The inverse of a relation R is written as R negative 1, like this. We read this right here as the inverse of R. We don't say R to the power of negative 1. That's not what that means. It is what it looks like, but that's not what it means. So R to the power of negative 1, we don't want to read it like that. That sounds funny. So we would say the inverse of R is blah, 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 right? So the inverse of R. So if we just have points, for example, this relationship here, right? If we just have these points, all we're going to do is switch X and Y. So whatever X is, whatever Y is, we're just going to switch it. 2, 0. The next point would be turns from 3, 4 to 4, 3. If we have negatives, same thing, just -2, -3. Notice the negatives and positives are not changing, right? So if a number is negative as an X, it's a negative as Y. If it's a negative as Y, it's a negative as X. No. And then we just switch 2, 4 and 4, 2. So we're just switching X and Y. That's it. We're interchanging them. All right. So if we are interchanging X and Y, we can also, this is how we would do it for points. We can also do so for both graphs and for equations. So we'll start with equations. And we will start with these 4 steps. So the first step is to replace f of x with y. So if we're going to switch x and y, we need there to be a y in our problem. So I'm going to change f of x into y. And then I'm just going to write the rest of the equation. That is step 1. If I'm going too fast or too slow, let me know. The second step is to interchange x and y, like change all the x's into y's and all the y's into x's. If there's more than one, like if it was like x squared plus x, then we would change it to y squared plus y, right? So if there's more than one, you change all of them. So the y is turning into x, the x is turning into y, y minus 3 squared minus 2, and that is step 2. Step 3 is that we want to solve for y. We want to get y by itself, right? So y by itself. So I see y is here. It's connected to that -3, then it's squared, and then it's -2. So I'm going to start from the outside in. So I'm going to go ahead and move the -2 to the other side. X plus 2 is equal to y minus 3 squared. That's going to cancel here. How do I get rid of a square? What's the opposite of a square? Anybody remember? A radical? Yeah, the opposite of a square is a square root. So I'm going to take the square root of both sides. Square root and square would cancel. And I've got the square root of x plus 2 is equal to y minus 3. And then the opposite of subtracting 3 is adding 3. I want to be careful here. This is a radical x minus, or the x plus 2 is inside the radical. The 3 is not. They are not like terms. So I'm going to go ahead and just write x plus 2 and my radical, and then I'm going to write plus 3 is equal to y. Hooray! We got y by itself. So step 3, definitely the longest step, right? Solving for y, definitely the longest. And then the last step is you want to write it back in function notation, which is putting it back with the -1. So since it started as f of x, we want f, or like the inverse of x. I'm sorry, the inverse f of x. So we're going to change the y. I'm actually going to use a different color, so I'm not getting confused. We're going to change the y into f -1 x. So the inverse of f of x is equal to the square root of x plus 2 plus 3. Okay. So one thing I do want to this is the end of our problem. One thing I want to share with you guys is that technically this function inverse does not exist. It exists, but it exists only under certain domains. We're not going to get super into this, but essentially what's happening here is if I have a parabola from the beginning, right? If I find the inverse of it, what's going to end up happening is it ends up looking like this, right? It's going to be sideways. So if it was a parabola, and then I'm flipping it over y equals x. So it's going to end up like this, like a sideways turn, like this. And when that happens, this is no longer a function because it no longer passes the vertical line test to be a function. So technically, this is not a function. So we shouldn't write it like that. We are going to write it like that for right now, but I do want you to have it like sort of in the back of your head that Miss Mac at some point one time told you that like there was maybe some funky things about this. Does that make sense? I don't want you to go to your professors in college and be like, that's not what Miss Mac did, because then I'm gonna look silly. So like there is a little bit of wiggle room here, but we're not going to worry about that right now. That's like a little bit more of a calculus skill. Okay. If you have more questions about that, we can continue to talk about that. Cool. Are we okay with this for now? Looking here. People are like nodding their head. They're cool with not going too deep into that math right now. So weak. Cool. Okay. So then the second way, so that's like with an equation. There is also with a graph, we can write the inverse. And the inverse, all we're essentially doing is switching the points. So if I see these 4 points are here, then I can go ahead and mark the points. I'm going to mark them in an XY table. So I'd say, okay, this is -1, 5. That's my first point. I would have -3, 3, -4, 1. Ooh, 1/2. Not quite at 1. And then -5, -3. Right. It's okay if your graphs are not perfect. If you're sketching, that is totally fine. Just want something to look there. So when I write my new one, I'm going to go ahead and flip these to 5, -1. This would be my function inverse. 5, -1, 3, -5, 1/2, -4, and -3, -5. So when I graph these, 5, -1 is here. 3, -3 is here. 1/2, -4 is here. And -3, -5 is here. And we can see that it creates this here, right? So it's kind of funky, but essentially what's happening is we are flipping over the y equals x line. We are, I'm gonna do it with the highlighter here. We are reflecting over this line here. If you can imagine, like here's the top graph and here's the bottom graph, I can flip them over like a pretty little butterfly, right? If you kind of like turn your head and look at it, you can see that it's the same on both sides. I just flipped one over the other like this, right? So that's what's happening when you're taking a radical. You're really flipping over the graph. So that's why I was saying over here with the parabola, if I think about this parabola being like this, when I flip it over this line, this one's going to be like this now. And this one here is going to be like this now, which is why it looks kind of like that. This is kind of funky. Math art, everyone. So exciting. All right. Okay, so we started with points, we did equations, and we did graph. Right? So those are like the 3 different representations that we have today. I do want to talk about functions and one-to-one functions. I want to also highlight there's a lot of words here. You don't need to write all these words down. Write what you think is the most important. Do we remember the vertical line test? Do you remember that? Maybe, maybe not. Some people are, Eric's holding up his finger like this. I love it. Yes, that's very helpful. So Kayla, can you talk to us about the vertical line test? What is it? What does it do? I don't know if you can come off mute right now. It's okay if not. No, you can't. Okay, cool. Somebody else want to talk to me about the vertical line test? What it is, what it means?
Basically, it's like talking about inputs and outputs. So it's the idea of not being able to have 2 different outputs for the same input. So when you're doing the vertical line test, I don't know if you can scroll back up to the example you had before, the parabola, the sideways one, or I can just explain from there. I don't know. But if you have a parabola that's sideways and you were to draw a straight line downwards, the line would be touched twice, which means there's 2 outputs for the same input.
Yes, absolutely. Sorry, Gali, my thing froze right as you were telling me to scroll. But you're totally right. if we have the sideways parabola like this, then when we pass a vertical line through it, it touches in two places. So that x value is not changing, but the y value is changing. So we would say that something like this is not a function. Where when we have something like a regular parabola, no matter where we put a vertical line, it's never going to touch two times. So this, we would say that the regular parabola is a function. So vertical line test tells you if it's a regular function or not. There is also something called the horizontal line test, which tells you if the inverse of your function is a function. So basically, like up here where we were saying like, okay, the parabola is a function, the original equation, and the inverse is not a function because it doesn't pass here. So if the first equation and the inverse equation, if both of those are functions, then it has a special name, which is that it is one-to-one. Okay, so if it passes the vertical line test and it passes the horizontal line test, then it would be called one-to-one. So what I do when I'm checking this is I check for vertical line test and I check for horizontal line test. So I run like a vertical line like this all the way up my screen, and I see if there's anywhere along that graph where it's going to touch two times. You might be wondering about this section right here, right? It looks like a vertical line would touch in both of those places. But what I know about a cubic function and what we should know about a cube root function like this one is that it's always increasing, even though it's really going up very, very slowly, right? Or in this case, it's going to the right very slowly. It is still like moving forward, right? So this one would pass, I'd say, yes. Oh, yes, pass. It passes the vertical line test because at no point am I touching it two different times. Okay. I'm going to do the exact same thing for the horizontal line. I'm going to go ahead and run a horizontal line like this and see if there are any places where it touches two times. And the answer is no, it doesn't. So it is passing the horizontal line test as well. So since it passes both tests, therefore, this is a 1-to-1 function. So because it passes both tests, it is a 1-to-1 function. That means that the function itself, like what we see here, this graph is a function. And when we take the inverse, it's also going to be a function. Kind of funky. This is mostly just vocabulary, guys. So it's okay if you're like, wait, what the heck? You just need to know, does it pass the vertical line test? Does it pass the horizontal line test? If yes for both, then it passes and it is a 1-to-1 function. That's kind of how I think about it. It's like if you're passing one class and you're not passing the other class, then you're not passing all classes. But if you're passing both classes, then you are passing all classes. So it has to like pass both. So let's think about this one as like as a non-example. So for vertical line test, I'm gonna go like this. Like, yeah, it looks good, there's nowhere. So this would be a pass. However, for the horizontal line test, when I run this line, I see that it touches, it touches way more than two times. So this is a no pass. So the inverse is not going to be like when we turn it on its side, right? When we turn it basically like 90 degrees, it's not going to pass anymore. So therefore, this is a function that's from the vertical line test, but it is not 1-to-1. It is not 1-to-1. Okay. looking at this today, what, if any, questions do we have? Or are we thinking about still? Any questions? Okay, cool. All right. For our practice time today, you have 3 options. You can go into your breakout rooms if you want to work with other people. I believe you should all be in like the right breakout rooms, but if you need to change them, please let me know. And then if you want, you can stay with me and we can work on the assignment together. If you would like to work independently, that is totally fine as well. You can just like stay here and work on your own. My breakout rooms are open. Can you guys see a little thing that says, oh, wow, that did not work. Okay, I'm gonna go ahead and close these and reopen them. Please hold. Recreate. Recover. All right. You should have a breakout room option at this point. If you'd like to go work with your friends, you're welcome to. If you are Janet, Amaris, or Maritza, just tell me what group you are trying to work with. Or if you just want to stay here, let me know. Janet, Amaris, you can message me or just come off mute. And Maritza? Maritza, you work alone? Okay, cool. So I'll put you into independent workspace and you can come back if you need to. Amaris, independent, cool. And then Janet, independent, cool. Awesome. Okay, my friends who are still here, can you either like raise a blue hand or tell me in the chat if you would like me to go over them? Raise a blue hand. Awesome. Thanks, Diana. Thanks, Kat. Thanks, Walter. Cool. Okay, do you guys have, Diana, Kat, and Walter, do you guys have the assignment open? Yes, yes, yes. Kat's got it. Awesome. Walter got it. Diana's got it. Cool. Okay, I will open mine. Can you guys see assignment 8 now? Sweet. Awesome. Thanks, Anna. Cool. Okay, so for assignment 8, you guys are going to drop in your notes from today, whatever they look like. And then you're going to tell me your random boring fact if you want to. I just want to like put faces and names together. And then we are going to jump in and do some inverses together. So it says state if the given functions are inverses. So what I'm going to do is add a little sticky here. I have some like place to write. Awesome. So if they tell us 2 functions and they want us to decide if they're inverses or not, then what we're going to do is we're going to take one of the functions and we're going to find the inverse of it and then see if that inverse is the other one, because there have to be inverses of each other. So every function only has one inverse and that function's inverse is opposite. So I'm just going to choose whichever one looks easier. Do you guys want to do f of x or g of x? Which one looks easier to you guys? Any opinions? Personally, I see that there's only one x in g of x and f of x has 2 x's. So I'm like, I don't love that one. Oh, some people do love it. Walter, let's do it. I'm here for it. All right, let's do f of x. And Jonathan wants that one too. So, okay, so I'm going to take f of x. I'm going to turn it into y. So y equals x plus 3 over 2x. And then the second step is to flip x and y. So I'm going to say, okay, I got x equals y plus 3 over 2y. Okay. So I need to get x by itself. So if I want to get x by its, I'm sorry, I need to get y by itself. If I want to get y by itself, I need them to be all in the same like playing field, like none of this division business. So I'm going to go ahead and multiply by 2y on top and on bottom. Like that. So I'm going to have 2y times x equals y plus 3. Like that. Okay. In order to be able to do all the things that I need to do, I need y to be on the same side. So I'm going to go ahead and move this y over here. So I have 2, I'm going to call this 2xy, just putting them in order, and then minus y, because that's not like terms because it doesn't have x with it, equals 3, like that. Okay, this is why I'm very glad that you chose this one. If I have the y in both parties, how do I get the y out of there? What can I do? Like, how do I make it into like one? How do I put the y's together? Any ideas? Plug. I don't know what that means, Walter. What does plug mean? Plug it into the equation. Oh, interesting. Oh, plug it in. Yeah, okay, that makes sense. Thank you for figuring that out. I want to get the y's together. I don't really have anything to plug in right now. So what I have to do is I'm going to actually factor out a y. So you know how there's like a y in each of these? I'm like GCF factoring. I'm taking the y out. So what I'm doing is I'm going to put the y on the outside. And what that's going to leave on the inside is 2x minus 1. This is like a nifty trick that I can do. Basically, I'm undistributing this one. So I'm taking the y out. I'm taking the y out. And that's going to leave me with 2x plus 1. Because if I distributed like y times 2x, I get 2xy. And y times negative 1, I get negative y. So I'm factoring that y out. It's still equal to 3. I still want to get, so now there's only one y in the equation. And it's being multiplied times that 2x minus 1. So I'm going to go ahead and divide by 2x minus 1. I'm going to take that whole thing, move it to the other side by division, 2x minus 1, like that. That's going to cancel this and leave me with y equals 3 over 2x minus 1. Like that. So I'm going to check, is that what g of x is? Yes, it is. Right? That is exactly what I have there. So the question says, state if the given functions are inverses. So since I took one, found the inverse of it, and it was that other one, that means that the answer to this question is yes. The answer is yes. So that is why when I look at my answer key, I can see the word yes is there and I can cross it out. I know there are probably questions here. What questions do we have about number 1? Do we want to try number 2 just to see? Cool, let's do number 2. So number 2, which one looks easier, x or y? I'm sorry, g of x or f of x in this case? No problem, Brendan. It's all good. G of x, cool. So we'll do g of x. So g of x, I'm going to find the inverse of g of x. So I'm going to put y equals negative 4x. That's the first step, is replacing with y. And now I'm going to flip them. So now I have x equals negative 4y. And then how do I get y by itself? What do I do? Divide, yeah, for sure. Divide by negative 4 on both sides. So I have y equals, I'm going to put the negative out front and put x over 4. That's like 1/4 x. So you could also write it like negative 1/4 x equals y. You can write it either way. I've gotten y by itself. Is this or this the same as that? Nah, it's not the same. So the answer to this question would be no. So I'm going to go ahead and cross out the no. So that would be how we do numbers 1 and 2. 1 and 2. So 3 and 4 are also similar. You can see there are only 2 yeses. So both of them should be inverses of each other, right? So you know the answer is yes. So now you need to figure out how to write the math part of it. And then for numbers 5 through 12, you're just finding the inverse. So there's no yes or no business. You're just trying to figure out, like, if this is the function, which of these is the inverse of that function. We want to make sure that you're showing your mathematical work there. Okay. Cool. You have 2 graph problems here at the bottom for part 3. You're just like sketching the graphs. They don't need to be perfect. You're just showing that you kind of understand how to move the points across, like in example 3 today. And then you have a checkpoint Google form, which is it's 4 questions and they're all multiple choice. So you're gonna check that out. Okay. There is some extra credit if you wish. If you want some additional extra credit, you can go for that. These are more like just like additional practice problems in case you really want to do better on it. All right. It is about that time. So if you're feeling good, you can go ahead and log off. If you have a question or you want to stick around for me to help you out, then I totally can do that. Otherwise, I'll see you on Thursday. Bye. Have a great day, guys. Thank you. Hi, everyone. Welcome back from those workspaces. Were they productive workspaces? Did we get started? Do we have any questions? All right. Feeling good? Cool. For your homework today, you have part 1 where you're just saying like yes or no, are they inverses of each other, and you're showing why they are or not. For part 2, you're just finding the inverse like we were doing on example 2. And then for part 3, you're doing the example of you're using the example of the graph. Okay, so those are the 3 parts. There is a 4th part today, which is a checkpoint Google form. It is 4 multiple choice questions. I just want to see, like, if it was ACT style, how you would do. You can use as much time as you need to complete those problems. Okay. If you have any questions, feel free to stick around. Otherwise, this is the end of our time together today, and I will see you on Thursday. Thanks for hanging out. Thanks for your uninteresting facts. It was fun. Bye, guys. Bye.
For the rest of your day.
Thank you. Have a good day. Bye-bye. Bye-bye. Nia, did you have a question?
No.
No, you're good to go?
Mm-hmm.
Okay.
I just forgot. I was just busy doing the other question.
No problem. All right. Bye.
Bye.